Good morning, everybody. I wanted to do a little video talking about graphing quadratic functions again, or graphing parabolas, and got a little practice assignment we're going to work on for this week. This week you're going to be given an option again. You can do this practice work. You can look at the practice work, look at this video, but some of you have already done a bunch of graphing of parabolas, so if you're comfortable with that work and you would rather work on the other option instead, which is just more recreational mathematics, feel free to do that. But your next essential assignment that we'll do next week will be on this topic. So watch the video, see what you think. But I've got two different parabolas here. And what I'm doing a little bit different this time is I'm going to compare my graphs to the graph of y equals x squared. Y equals x squared is going to be called our parent graph. And the first one I have is y equals x squared. And then I've got another graph underneath it, which is y equals 1/3 x squared. And so what we want to talk about is what the 1/3 does. So the only difference between these two equations is the x squared and the 1/3. So maybe I should write that on the graph. This orange one is y equals 1/3 x squared. The white graph is just your normal y equals x squared. That's the parent graph. So, without further ado, let's talk about it. Got a lightsaber here to help. Y equals x squared. Well, that one, all I do is, I always start with these 5 points, just because it gives me an easy graph. And if I plug in 0 to x squared, 0 squared is 0, 1 squared is 1, 2 squared is 4, but same again with the negative numbers. Negative 1 squared is positive 1, negative 2 squared is positive 4. So if I do all that, graph these points, negative 2 up to 4, negative 1 up to 1, 0 stays at 0, 1, 1, 2, 4. I could go further. 3 squared is 9, so the graph goes all the way up to here. 4 squared would be 16, way up there. So it goes, you get this general shape. The question is, what happens when I multiply this, the x squared times 1/3? Well, if you multiply by 1/3, it makes the graph seem fatter. And it's because you're taking every y value and you're multiplying it by a third, which is the same as dividing by 3. So you're like pulling it down. If you pull down all these points, it squishes the graph vertically. And so it gives you this shape. And it makes sense with the points. If I do 0 squared times 1/3, I still get 0. 1 squared is 1, but then I multiply it by a third, I get 1/3. 2 squared is 4. 4 times 1/3 is 4/3. Now 4/3, so if I go to 2, 4/3 is going to be 1 and 1/3. It's the same as 1 and 1/3. So it's smaller. Took 4 and divided it by 3. So all of these points got shifted down or compressed down. And 9 times 1/3 is 3. So that's the shape of this graph. So to compare the two graphs, you would say it's a vertical compression by a third, but it gets squished vertically. That's what happens. Also notice that 1/3 is a positive number, so the coefficient is positive, so you have like a happy face shape. So let's look at what happens when it's negative. Over here I've got this function, y equals x squared, and underneath it's y equals negative 2x squared. So I should write that there. This is y equals negative 2x squared. And you can already see from the graph that y equals x squared is this. It looks a little bit different than my other one, and it's because you can tell my scale is different here. I made my x values wider. It was just to make this graph fit more. But otherwise it's the same graph, the exact same table as the other problem. But now what I'm doing is I'm multiplying each of these y values by a -2. So 4 times -2 is -8. Because what am I doing? To get -2x squared, I square -2, which gives me +4, that one up there, and then I multiply by a -2, that -2 in front. -1 squared is 1. 1 times -2 is -2. 0 squared is 0, times -2 is still 0. And then these also come out to be -2 and -8, because I'm just multiplying each of these y values. These are the ones I already squared. I'm multiplying each of these by -2. That does two things. It stretches the graph vertically and makes it look skinnier. It also flips it upside down because it's negative. When this number in front is negative, it's like a sad face. So I get -2 all the way down to -8, -1, -2, 0, 0, 1, -2, 2, -8. That's my graph. There are a couple things on this graph, some things to talk about. This point here is the vertex. The y-axis is called the axis of symmetry. We'll talk about that a little bit more later, but wanted to get you started with those. So that's today's video, and you have some problems on the practice that are just like that, where you start with this graph and then you draw the new graph and you compare the two. Try to talk about how they compare. That's it. If you have any questions, let me know. Have a good day.